am I audible?
Yes, sir. You are audible, but voice is somewhat low, sir. Please check.
Okay. Yeah, decision tree is the topic. Just I will introduce give the introduction about the decision tree. Then we'll take one problem on it, manual application, and the implementation process. So before going to start it, so where it comes, the decision tree. We have seen machine learning, the definition in the previous sessions, and we have seen the types of learning like supervised learning and unsupervised learning. So in supervised learning, we have seen regression models and classification models. So in regression, a purely regression problem is linear regression, and purely classification model is logistic regression. So after this, only these two models like linear regression and logistic regression belongs to supervised learning, and linear regression can do only regression, and logistic regression can do only classification problems. Here now our topic is decision tree. Decision tree. This model, this algorithm can do both. It can do regression and it can handle the classification problems also, classification data also. So here decision trees belongs to supervised learning model, can do regression and can do classification model. Here the main intention is to, for the given data set, for the given data which is a supervised learning data, so it definitely have some target variable and will have some features and target variable are there, so it is a supervised learning. Now if you apply decision tree, the main intention is to, for the given data, it is going to convert into a tree format. Okay, a tree it is going to form. You know, a tree is a hierarchical representation of data, level by level representation of data. So in that form we are going to represent our data set. Then after building a tree, after forming a tree, we are going to traverse the tree to find out the hidden output or for the prediction. That is the introduction about the decision tree. In decision tree, we are forming a tree, hierarchical representation of data for the given data set. We know the tree contains leaf nodes, root node, and intermediate nodes. Leaf nodes, root node, this is a root node, and intermediate nodes also called attributes, and at the end we'll have leaf nodes, leaves like a tree format, root node, attributes, and leaf node. This is tree structure. So whatever the data set they have given, that is converted into tree format. This is a main thing of decision tree. Tree representation in problem solving. So this is a different from previous sessions. So I think you already learned logistic regression and linear regression. This linear regression and logistic regression, you can observe one common point is we are going to form a equation for this. That's why it is called a parametric method. The linear regression and logistic regression, in this we are going to form an equation for the given data set. Just we are going to find the best fit line. That is called a parametric method. But here in decision tree or k nearest neighbors, these all comes under non-parametric method. Non-parametric method. In this, we are not going to provide a best fit line equation. We are not providing a best fit line equation. We are directly learning from the data and providing the final output. Like if it is a decision tree, we are finding a tree format. If it is a KNN, we are finding the best K value. In these are two comes under non-parametric methods. So in that first one is decision tree. It is representing the data in tree format. This is for problem solving. You know, Whenever our data set has 1,000 rows and 5 to 10 columns like features, 1,000 rows, then reading the data is very difficult if that. But if you are converting the data into a tree format, then it is easy to find out the solution or to predict the answer. Understood? So that's why this is the main intention of decision tree. Here, main task is to find out what will be the leaf node, what will be the attribute, and what will be the root node. We have many features like column 1, column 2, column 3. Many features are there. Out of these many features, which one we can make it as a root node, which one will be the intermediate node, and what we can make as a uh, leaf node? That is our question. That is a question in this. Okay. Intention is to convert the given data into a tree format. Okay. But in a tree, what node will be the root node? What attribute will be the intermediate node? What attribute values will be the leaf nodes? So that is the main intention of this. For example, you look at here, uh, who likes computer games? In this example, who likes computer games? These are the computer games is the target variable. Means they may like the computer game, they may not like the computer game. So yes and no are the target variable values. Target variable values are yes and no. Who likes the computer games? And they have given the features: age, gender, and occupation. Age, gender, occupation. Based on this, we are going to say whether he will likes the computer game or not. Now here, directly the right side, a tree is formed. A tree is formed. In that, age is taken as the root node. Age is taken as a root node. Whatever the age, complete age is divided into greater than 15 or less than 15. Only whatever it is, a continuous value: 1 2 3 4 5 6 20 30 40, like that. Age will be anything, but we are taking that into only two categories: continuous values, that is like the age may be 16, age may be 20, or age may be 30, or age may be 8, age may be 7. These are the values, but these are continuous values are converted into categorical values, whether it is greater than 15 or less than 15. So if it is greater than 50, we are saying yes, otherwise no. Yes, no, yes, no. This is a conversion problem. Now gender also, we know that male, female, male, female, like that, these values. And occupation, whatever the job they are doing, private employee or government employee or business. So some of the occupations may be like this. Okay. Now it is converted into a tree format. In this, age is selected as a root node. Age is selected as a root node. If age is less than 15, here it is yes, unfortunately. Here we got no. Yes, this is no. If age is less than 15, then we are moving to this side. If age is greater than 15, other side we are going to say. See here, directly we are giving a result when age is not less than 15. Means for this call, for this at the root node, if the answer is no, then we are directly saying that person will not interested to play computer games. The person whose age is greater than 15, he is not at all interested to play computer game. Directly we have given the answers. And if it is yes, means age is less than 15, then we are moving to the other side. Now we are checking gender. Gender. He is a male. Yes. He is, otherwise he is not a male. This way. So now here the percentage predictor score, how much he or she will be interested to play chess game, sorry, computer games, that is here we represented. Okay. Totally, this is the way we have represented the given data into a tree format: age, gender, occupation, and whether they interested to play computer games or not. So totally 4 columns. This is 3 plus 1, we can write 3 plus 1, because one is a target variable and remaining 3 are the features. So here, to select the attributes, three attributes, we are going to take the only features, and the target variable will be at the leaf node. Target variable values we are taking at the leaf nodes. target variable will be considered as a leaf nodes, and remaining all features we are taking as a attributes for deciding factors to the leaf node. These attributes, in these attributes, so which one will be act as a root node and which one will be act as a intermediate nodes. So after root node, what node we select as a root node, and after that which node we should select, and after that how we can continue one by one until we get a leaf node. So here we selected as a age as a root node. So instead of age, why won't we select gender as a root node or occupation as a root node? Let's try. Instead of age, why won't we select gender as a root node, occupation as a root node? Here, only two attributes. When we selected age as a root node, only two attributes we are considering, one and two attributes we are considering. Okay. And remaining occupation, we are not at all considered, but finally, we are giving the output. Without considering the occupation, we are directly giving the output just when we are considering age and uh, gender. Only two columns if you are taken. Okay. If you are changed the root node to gender like this, gender is a root node and gender may be male or female. If it is male, what should we check? If it is female, what should we check? Understood? If it is age, then intermediate node also we have selected. So if the gender is male, what we should select, and if the gender is female, what node we should select. For example, let's say if gender is male, we are going to check age, that is greater than 15 or less than 15. Greater than 15, yes. Less than 15, greater than 15, no. Again for female also, again we should select greater than 15, yes and no. Still, we haven't get the result. You can check here. You can check it. Same. From this, the conclusion is less than 15 age and male persons are interested to play the games. From the first tree. From this, we can understood. From this, we can understood less than 15 is age, and if he is a male, 15 below 15 male persons are interested to play computer games. That is a conclusion. But instead of taking age as a root node, if we are going with gender as a root node, and male we have considered and female we have considered, okay, and greater than 15, yes, no, then he will be interested, this row, this part will be interested to play game, but this part and little bit of this part also interested to play computer games. This part people will not interested, and this part will people will not be interested. Here, if we change the root node, then the tree size is increasing, that I want to say here. Understood? So randomly selecting a root node randomly is not a good idea. Selecting a root node is randomly, it's not a good idea. So if you are selecting a root node and intermediate node, now the tree size will be compressed less. So if you are randomly selecting, maybe the tree size will be increased or decreased. That is not a good thing. That but sometimes we are going to check each and every column, each and every point we need to check to decide the output. But that is not an optimal tree. Optimal good decision tree means, so the tree size must be very less. And within a 2-3 intermediate node, we should predict the output. That's why the optimal tree we need to select. This is also decision tree. This is also decision tree. This is also decision tree. And we can uh, uh, create many decision trees. Like we can take occupation also uh, a root node, occupation also root node, and uh, after that we can select age. After that we can select anything, any intermediate nodes we can, many combinations we can try. But which tree is less in height, sizes means less height, so that tree we are going to select. Less height means the travel cells time will be reduced, so we can easily predict the output. Within a short time we can predict the output. That is the main intention. Okay, first of all, decision tree means forming a tree from the given data set. Forming a tree from the given data set. Many trees we can form, many trees we can create, but the thing is optimal best tree we need to create. Means when we can say that is the best, good root node we should select. That will directly deviate the output. So that is the main intention of decision tree select. For example, one more data is here, attribute 1, attribute 2, attribute 3, and the corresponding class. This is our target variable. Here we have three columns, means three features and one target variable. So our first intention is to, so first we are going to split the data into training. This data I'm using for training and this data I'm using for testing. So from the training data, I'm going to train the model. Okay, train the model means I'm building a tree, building a tree. So after building a tree, I will check the metrics and then apply for testing. This is the whole process of ML application. So this is a simple data set. Three attributes are there. One is a target variable. For example, if we build a tree like this from the training data, so what is that? Refund we have taken as a root node, and marital status as an intermediate node, and taxable income is another intermediate node, child node. Okay, see here, once we if we check the refund, if you are taken as a root node, when refund is yes, directly we are giving the output leaf node, that is no. Okay, when refund is yes, look at the refund yes and cheat no. uh, Refund yes and cheat no, refund yes and cheat no. So here it is directly proportional. When refund is yes, output is no. Let's target output is no, he's not going to cheat at all. This is the target variable. These are the features. So why, now you can easily understood why refund is selected as a root node. This, at one sense, when refund is yes, we are directly no need to check all these columns, these two columns. No need to check these two columns values. When refund is yes, then directly we can predict the output as no. That's why here refund is selected as a root node. Now, how we can find out these combinations? How we can find out this proportional? How we can find out this proportionalities, we'll see in the next slide. Now, when refund is no and refund value is no, then we are going to consider remaining columns. When then refund is no, then we are going to consider remaining columns. Out of three, one is selected as a root node, and remaining for that root node, if the answer is no, then which one should consider as another intermediate node? Okay, here marital status we have taken as a intermediate node, right node of refund. Why we have selected this again? Why we have selected this again? Instead of here, we can also have taxable income. Why this node is selected as right node of refund? Understood? So there is a logical thing again here. When it is married, when he is married, like when refund is no and he is married, so directly it is going to be no. Okay, no married combination, no married combination, no married combinations, no married combinations. We can see the output no, 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 no married combinations. Directly we are giving the answer. That's why. Instead of, if we are going to select the intermediate node as taxable income, we can't get the output in much fast. Okay, if taxable income, now we are selecting, now we are dividing again. This is the last case of giving the answer. Understood? So there are three columns in the given data set, three columns, the three features. So which features we should select as a root node? So that is our big question in decision tree. We are not selecting a root node randomly. There is some logic is there. There is some logic, like proportionality, how the target variable is behaving with each and every feature. How target variable like cheat is behaving with the features. How refund is influencing cheat. How taxable income is influencing cheat. How marital status is influencing you. What is the relationship between features to target? What is the relationship between features to target? That relationship we are finding. Understood? If there is no direct relationship, if refund is yes, what is output? The if when refund is yes, all the cases, when refund is yes, all the cases we have no, output is no, target variable value is no. Then that relationship we found, and we have directly taken as a root node as refund. That is a good thing here. But for the refund also, for the refund is yes. If you have two answers, yes and no, again this may not be the root node. Maybe which column or which feature more influencing the target variable, that feature will be selected as a root node. Understood? So our topic is decision tree, forming a tree from the given data set, forming a tree from the given data set. It can do both classification problems and it can solve both regression problem. Regression it can do, classification it can do. It is a supervised learning because there is a target variable, so it comes under supervised learning. Now here, forming a tree. So when we come to the tree, right, hierarchical representation, so one by one, level by level representation, what will be the root node for the given data set? Many columns are there, many features are there. Which feature we can select as a root node? That is a big question here. Understood? So here answer is, which feature is more influencing? Means probability way. When it is yes, how many times the target is yes? That purity levels we are calculating. So when it is raining, what is the chance of going to the college? That purity levels. 100 days it is rained and 90 days you came to college. 90 by 100. So these purity levels, probability levels we are calculating. Okay, for all the columns with respect to the target variable. With respect to the target variable, for all the columns we are calculating these purity levels. So which column or which feature has the highest purity levels, that column will be selected as a root node for the given data set. That is a thing. The purity levels we can select, the purity levels we can select to decide the root node. Here, after training, now we have built a data. Now how we can find the answer for the given test data? The first row is refund no, status is married, and taxable income is 80. So what will be the output? For this, directly check what is a refund, what is its value. Refund value is no. So move on to the right side. Move on to the right side. Now check which column it is there. Here we need to check marital status. It is married or single or divorced. So three options are there. So here the given in the given test data, the answer is married. So we should check married, and the answer is, if it is married, there is no ambiguity. So no other attribute to check. Understood? So directly we can say the answer as no. Understood? So this is the way we can build a tree, and we can test the given data. So here, as I said, the primary thing, the main intention in decision tree is to select the nodes. Either a root node, what will be the right node of root node, what will be the left node of root node, what will be the next intermediate nodes, not only the root node, what is the structure, hierarchical representation, which feature we should select first, which feature we should select second, and which feature comes under third. So that priority we are giving, and based on that we are making as a root and subordinate nodes in tree format. For that we are following entropy and Guinea format. As I said, entropy and Guinea format. For selecting a root node or selecting its intermediate nodes, we are going to calculate the purity levels. Purity levels in the sense how a column or how a feature is behaving with the target variable. How a feature is behaving with the target variable values. If the feature value is no, what is the target variable value? If the feature value is yes, what will be the target value here. If the feature value is yes, what is the target variable answer? If the feature value is no, what is the target variable value? So that purity levels we are uh, calculating whether there is an impurity or 50-50 percentage. So that thing we are going to select 70-30, 50-50 or 100%. If in feature one, when it is yes, always the target variable is saying no. When feature one is yes, target variable always no. Directly. Directly relationship. If first feature is yes, target variable answer is no. First feature is yes, target variable answer is no. So in that case, so we can say directly this node, this feature one will be considered as a root node because the purity level is 100%. Purity levels means it is not mixed. It is not mixed. Right? It is 100%. Whenever it is yes, the output is decided. No need to check other columns. Whenever output is yes, no need to check other columns. Whenever the output is no, then you can check the other columns. So further, to calculate that purity levels, we are using entropy and Gini index. We are using entropy and Gini index. Entropy will say certainty levels, uncertainty levels, how the output is changing, or output means target value. Target variable values are changing or behaving with respect to each and every features. Each and every feature. Column 1, column 2, column 3, or feature 1, feature 2, feature 3, and target variable, how they are behaving respect to target variable, how they are behaving. So that purity levels we are going to calculate in entropy. So the equation for entropy is, this is a probability of all the columns in all column values, probability of all column values into log base 2 we are taking here, and the probability of same. Okay, here for all columns, for example, if there are yes and no, what is the purity level of yes, what is the purity level of no? Means column 1 yes no are there. In target variable, what is the value? What is the value? If column 1 is yes, target value is yes. Column 1 no, column 1 is value is no, and target value is yes. What is the purity levels here? So that thing we are going to calculate for each and every column. We are going to check purity levels. Then certainty levels, whether it is any fluctuations are there or directly it is going linear. So that thing we are going to find out with this equation, the entropy. Next, information Gini we can calculate. Uh, this entropy we can calculate for all the columns. After calculating entropy for all the columns, then we are going to calculate information Gini for all the columns again. So here which column has the highest Gini with respect to target variable? Which column has the highest Gini with the target variable? That column will be selected as the highest node, means the root node. So information Gini will be calculated as entropy of target variable, entropy of target variable minus entropy of target variable with respect to each and every column. Target with respect to x representing the input data like features. This is a target variable minus entropy of target variable minus entropy of target over features. Means how the features are influencing the target variable, that decided here. How the features are influencing the target variable, that will be decided here. That will be taken in information Gini. So I will take an example, textbook example. There are 14 rows and 4 columns, 1 target variable. This is a target variable. The values are yes, no, yes, no, yes, no. Play games, play outdoor games, whether it is tennis, golf, or cricket, any game, outdoor games. For that, we are going to check the weather. Weather may be outlook. This is a feature 1, feature 2 temperature, feature 3, and feature 4. 4 features plus 1 is the target variable. 4 features, 1 target variable. Just observe the values of target variable. Target variable is distributed over yes and no. So it is a classification data because only categorical values. Y values are repeated over 2. So it is not a continuous value. So it is a classification problem. Now look at here. Outlook, a feature 1 repeated over sunny, overcast and rainy. Temperature repeated over hot, mild and cool. Three values. Humidity high and normal. Wind weak and strong. That is only 2. For this wind, 2 columns, 2 values. Normal high for this also 2, and here we have 3 values. Outlook also has 3 values. Target variable has 2 values repeated. Now 14 rows they have given 4 features, 1 target variable. Now for this, out of these 4 features, out of these 4 features, which feature we can select as a root node? Either outlook or temperature or humidity or wind. For that, what we are checking? See here, when it is sunny, what is the purity level? How it is behaving? See, if you check sunny, sunny, and here is also sunny, here is also sunny. Okay, once you can observe the results, when it is sunny, 2 values we are getting. Okay, the first column x1, when it is sunny, the last column target, 2 values. Yes is there, no is there. So that purity level is very low. And you can check overcast, overcast, and you can check yes, 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 and yes. This has the highest purity levels. Like that, we are going to check certainties. We are going to check for each and every column value with respect to target variable, that entropy and Gini we are calculating. Which column has the highest information Gini? Either x1 or x2 or x3 or x4. Out of these four, which column has the highest information gain? That column will be selected as a root node in the decision tree. Okay, now I have taken the target variable. This is a target variable. Now total 14 rows are there. Total 14 rows are there. You can observe, you can count here in the target variable, totally number of yes and number of no. Here I'm calculating entropy of target variable. Entropy of target variable. Just look at entropy of target variable. Uh, First, we are calculating entropy of this target variable. This we have selected this as a target variable. So out of totally 14 rows are there, 14 rows, 9 yes are there, yes are 9 and no's are 14, 5. So totally it is 14. Now for this, just target variable entropy we are calculating. Same we are substituting yes or 9, no or 5. Okay, totally 14. Now I'm calculating summation of probability of all values. Probability of yes log 2, probability of yes minus probability of no log 2, probability of no, like that. It is probability of yes probability of yes minus probability of no. Minus means here I'm doing summation, that's why log of probability of no. Here we can say how many times. This is the entropy of target variable. Now probability of yes. Probability of yes is repeated 9 times out of 14. That will be the probability. So we can write 9 as 9 by 14. 9 by 14 log to 9 by 14. Next, probability of no. 5 by 14 log 5 by 14. So if we calculate this, if we compute this, we'll get the entropy of target variable, that is 0.94. Just we have calculated probability, it's entropy of target variable. Entropy of target variable equation is P log P. P representing probability of probability log probability. I is representing values. In target variable, only two values are there. That is yes and no. If a column has three values, for all the values we should calculate the entropy. Now here entropy of here no need to confuse here. Here we have 0.36 and 0.64, that will be the 5 by 14, and this will be the sorry 9 by 14 value. So once they have divided and substituted in the log equation, no need to confuse. So if we compute these values, we'll get the entropy of target variable is 0.94. Now we'll calculate this part is completed. This part information Guinea we should calculate for each and every column. For this, entropy of target variable is done. Now we'll calculate entropy of target variable with respect to each and every feature. Entropy of target with respect to x1, target variable with respect to x2, target variable with respect to x3, target variable with respect to x3. What? Entropy. Entropy. Now we have calculated this one. Entropy of target is directly 0.94 minus this one. So for all four information, Gilly will calculate which column, means when we have taken x1, x2, x3 and x4, which column is providing the highest information Guinea, that column will be selected as a root. Now, entropy of target variable is done. Now we'll calculate entropy of the first column, that is x1. First column x1. You can look the first column is x1, x1. Here the values of x1 outlook is sunny, overcast and rainy. Three variations are there. Three different values are there. That is sunny, overcast and rainy. Three values. It means these x1 values are repeated over 3. Understood? X1 values are repeated over 3. Sunny, overcast and rainy. Only 3 values are repeating. So we need to calculate the entropy of outlook is entropy of sunny, entropy of sunny, entropy of overcast, entropy of rainy. Understood? And we are giving weightage to that. This is not equally distributed. You know, sunny values are we have 5, and overcast we have 4, and rainy values are 5. So for that we are giving weightage, means a percentage wise we are giving, not equally distributed. So percentage also we are giving. Next entropy of sunny will calculate. How we can calculate entropy of sunny? So total sunny values are this. Okay, so how many sunny values are yes, how many sunny values are no? Look at here. In first column it is sunny and the last column it is no. In the first column it is sunny and the last column it is yes. So that purity levels we are finding. That purity levels we are finding. Okay. Now this is what? Sunny we have totally 5 rows, 4 rows and 5 rows. Out of these 5, totally we have, this is a target variable values. Target variable values are disputed over yes and no. Target variable is whenever it is sunny, target variable is yes 3 times. Whenever it is sunny, target variable value is 2 times no. Now, whenever it is overcast, target variable value is yes for 4 times and 0 for no. And rainy, 2 times it is yes and 3 times it is no. So now just I am calculate sunny entropy. Sunny entropy. How we can calculate? Same probability minus this one. This one. 3 yes are there out of 5 log 3 by 5 minus 2 by 5 log of 2 by 5. This is the entropy of sunny. Entropy of sunny. Now I'm calculating here entropy of overcast. You can follow up. Entropy of overcast is equal to, so 4 yes are there. So 4 by 4 log of, here we missed, minus 4 by 4 minus 0 no's are there. 0 by 4 log of 0 by 4. This is entropy of overcast. Now entropy of rainy is equal to 2 by 5 minus here minus 2 by 5 log 2 by 5 minus 3 by 5 log 3 by 5. This is entropy of sunny. Entropy of sunny is here. Entropy of overcast. Entropy of rainy. So 3 entrophies we have calculated. Now final entropy means actually our intention is not to calculate entropy of sunny, entropy of overcast, entropy of rainy. Our intention is to calculate entropy of outlook. That is entropy of that complete column values. Entropy of outlook. Now here, how we can calculate entropy of outlook? Yes, it is indirectly. How many sunny values are there? 5. How many overcast? 4. How many rainy? 5. So individual entrophies we have calculated and we are multiplying with the weightage. We are multiplying that weightage means entropy of 3 comma 2. What is that? Sunny. Entropy of overcast, entropy of rainy. This is what we did. And here probability of sunny, that is a weightage. Probability of sunny is how many times it is done sunny out of 14. Totally 14. How many times it is sunny? So that we can write 5 by 14. 5 by 14. Here probability of overcast is 4 by 14. Here probability of rain is 5 by 14. Now when we compute these all will get entropy of overcast is 0.693. Entropy of overcast is 0.693. So in this way, this first column we have taken, we have calculated entropy of first column. Now we'll here the simple calculation. Entropy of outlook. Here entropy of first column, it is 0.63. Here in detail calculation is there. Just what we did, 2 by 5. 2 by 5. This is no part, and this is yes part. No need to confuse. 0.971. It is 0 obviously, and 3 by 5, 0.971. This both are same because no changes in that. Next, total entropy of outlook is the weightage 5 by 14 into 0.971, 4 by 14 into 0, 5 by 14 into 0.971. This is a final entropy 0.693. We'll talk about this one later. Next slide. Gain. Okay. As of now, calculate only entropy of each and every column. Now look at entropy of windy. We'll calculate entropy of wind. Now entropy of windy, that is the last feature, x4. X4, entropy of windy. So wind values are repeated over two, only weak and strong wind, weak wind and strong wind, weak wind, strong wind. So like that, what is the entropy of this wind with respect to the target variable, with respect to the target variable, entropy of wind will calculate. So how many weak are there, how many strong are there, here it is segregated. Wind column we have taken, and this is okay. So instead of yes and no, it is strong and uh, here only we'll calculate that without confusion. Okay, now here how we entropy of weak will calculate first. Entropy of weak, and here we'll calculate entropy of strong wind, entropy of strong. Now just we should calculate uh, how many weeks. Week 1, 2, 3, 4, 5, 6, 7, 8. So it is divided over 8 by 14. And this is remaining 6 by 14. Done. That is the weightage of weak and strong. Now in weak itself, how many yes and how many no? When it is weak, no. Weak, yes, 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 and weak, no. So it is second one. 1, 2. That's it. So only when it is weak, there are no values are 2. That's it. 2. Now we can calculate entropy as 2 no's are there and remaining 6 are yes. Yes. 1, 2, 3, 4, 5, and 6s. So the entropy will be here. Totally how many weeks? Week is 8. So okay, minus 2. 2 is nos by 8 into log of 2 by 8 minus 6 by 8 log of 6 by 8. This is the entropy of weak. So that will be that should be added. Now entropy of strong will calculate. How many strongs are there? 6. When it is strong, what is the value? No. Strong, no. Strong, no. 2. Strong, no. 3. So it is 3 by 3. Now 3 no's by out of 6 log of 3 by 6 minus, if 3 no means 3 will be yes. Yes, this is the entropy of strong, and we have also calculated entropy of weak. Now entropy of strong and entropy of weak we have calculated. Now just multiply with this. This one will be multiplied again same manner, 6 by 14 and 8 by 14 into this one. Both the terms if we add it, then we'll get entropy of wind. Entropy of wind will get. That is we have calculated here. Entropy of wind we got as uh, entropy of wind 0. Entropy of wind is strong, I think it is strong and weak. So totally 0.892 is the entropy of wind. So same way we can calculate Gini, we will calculate later. Now entropy of outlook we already calculated, that is 693, 0.693. Entropy of wind we calculated 0.8932, and entropy of humidity and temperature also calculated 0.911, 0.788. So after calculating these entrophies of each and every column, entropy of each and every column, after calculating this, now information Gini we are going to calculate. This is the process of information Gini calculation. That is, information Gini is entropy of target value minus entropy of target with respect to individual features. Entropy of target with respect to individual features. So entropy of target variable, individual, one target variable, we already calculated. Entropy of target variable is 0.94. That is common. Target variable is common. Entropy of 94, 0.94, 0.94, 0.9. It's an entropy of target variable. Now, entropy of outlook we have calculated. Entropy of outlook. Entropy of outlook is we got 0.693. 0.693. And entropy of temperature, entropy of humidity, entropy of windy. So totally the information Gini we got as 0.247, 0.029, 0.0152, 0.048. Now you can, so which column is maintaining highest purity level? Means we have taken all the columns with respect to the target variable. Which column maintained a good relationship? Which column is maintaining relationship? Good relationship with the target variable means that value, highest relationship. All the columns are maintaining good relationship, but which column is maintaining uh, highest one? That is called a information Gini. Now you can look at the information Gini of target variable, sorry, entropy of target minus entropy of column outlook, entropy of target variable minus entropy of temperature, and we subtracted it. This will be the information Gini of outlook, information Gini of temperature, information Gini of humidity 0.152, information Guinea of India is 0.052. Out of these four, uh, outlook information Guinea is highest, larger value 0.247 is greater than all. So information Guinea of outlook is highest out of these all columns. So we are taking outlook as the root node for this the given data. Outlook as the root node for the given data, because outlook is maintaining highest information Guinea when compared to other columns. Now outlook is decided as a root node. Now outlook values are like sunny, overcast and rainy. Outlook values are like sunny, overcast and rainy. When outlook is sunny, what need to do means we have three more columns: temperature, humidity and wind. Three columns are there. One column we have decided as a root node and three are left. When outlook is sunny, which one we should select? Which column we should select? Which values we should select? When outlook is rainy, what should we do? When outlook is overcast, that is which column we need to select. When outlook is overcast, we can just look at the entropy of overcast. Here we got 0, so there is no second option. There is no second option. When outlook is overcast, directly we can say, we can give the output. There is no impurity. It is completely pure, cleaned one. When outlook is overcast, no need to check other columns, no need to check. Directly we can say the target as yes, we can play the game. But when the outlook is sunny or when the outlook is rainy, what we need to do? Which column we should check? Understood? This is just one part. Just we decided the root node as the outlook. So for that, we are going to split the data. We are going to split the data in terms of sunny, in terms of rainy. Means with respect to sunny columns are 5 and rainy columns are 5 are there. Rainy 5 is there, sunny 5. Here. 1, 2, 3, 4, sunny 5 columns and rain also 5 columns are there. So with respect to that, with respect to sunny, with respect to rain, we are dividing the data set. When it is outlook is sunny, Now remaining columns, how they are behaving, that way we are dividing. Look at here. When outlook is overcast, directly we can say yes, no need to check remaining columns. Now when the outlook is sunny, there is a impurity, yes is there, no is there. For that we are going to take a second option. What option we need to select? Either we should select temperature, or we should select humidity, or we should select windy. Again, when outlook is rainy, there is no direct option, direct answer. Yes and no, both are there. So again, we need to check for the second option, second opinion. Either to check temperature or humidity and wind. So which one we should consider? Understand? So for that, this is done. This is done. No need to take this one. Only two columns, two parts we are going to consider. Now sunny, our outlook we have taken as a root node. Now this is also not considered. Again, this will be our mini data set over that. Mini data set. This will be our mini data set. Again, from this, we are going to calculate entropy of target variable, entropy of temperature, entropy of humidity, entropy of wind. Again, we'll calculate entropy of each and every column, and we'll calculate entropy of information guinea of each and every column. For which column will get highest information gain, that column will be suffixed. So that column will be suffixed here, hence will be taken as an intermediate node. With respect to sunny, with respect to sunny, which column means it may be temperature, it may be humidity, or it may be wind. Here also, it may be temperature, it may be wind, or it may be uh, humidity. So for this, out of these three, which column has the highest information guinea, that will be assigned here. With respect to rain also, which column has the highest information guinea, that will be selected as here. Next. So for that, what we should do? Again, calculate the, for example, here we are taking same entropy of playing a game. How we can calculate? Totally 5 rows are there, 3 no's, 2 yes, 2 yes. So here information in entropy of this one is minus 3 by 5 log of 3 by 5 minus 2 by 5 log of 2 by 5. This is information entropy of target variable. Now entropy of we'll go with this humidity. Totally 5 values are there, 3 high, 2 normal. 2 normal. Then look at here, uh, humidity. When humidity is high, the answer is directly no, 100%. So here we'll get entropy as 0. And here when it is normal, 0. Next, when wind is weak, two options are there. Wind is strong, two option means purity levels, mixed data. Purity levels are 0. Impurity is there. Here also again hot. When it is hot, no. When it is mild, yes and no. When it is cool, yes. So we can get information guinea of humidity is greater than temperature and wind. When for the sunny attributes to attach here, maybe here we get yes, sunny will get when it is sunny we should check wind. Means this one will get the highest information guinea. Next here when it is rainy we should check the humidity. As you can clearly observe here, wind purity level is very high, purity level is very low, impurity is high, purity is low. Weak, two values are there, strong, two values are there, two values. Weak, weak, yes is there, sorry, no is there, weak, no is there, weak, yes. Means when it is answer is weak, we have two options. Now like it, check it. Humidity is high, humidity is high, humidity is high, answer is directly no. Humidity is normal, answer is yes. So pure, it is 100% pure. Now here, when it is hot, answer is no. When it is mild, only the answer is changed. And again, when it is answer is cool, again. So out of wind, wind, humidity and temperature, humidity and temperature, entropy is very high. Entropy is high. Now, when rainy is we are taking, what output we should select? When sunny is there, which output we should select? So here we are not going to check another column, temperature. So without checking that, we got the answer directly here. So this is means very optimal decision tree we need to build. Very optimal decision tree we need to build means uh, without increasing the height. So actual goal of decision tree is to actual goal of uh, decision tree is to build a tree from the given data set, form a tree. But very optimal tree we need to form. Optimal tree means height of the tree must be very low. Height of the tree must be reduced. Understood? So this is the decision tree. Overall, when we have a data set, we need to split the data into training and testing. So on a training, we are going to build the decision tree and we are using the tree for the testing purpose and will decide the accuracy and the remaining. If it is a classification, we'll go with accuracy, precision, recall. Otherwise, if it is a regression, we'll going to calculate mean square error or mean absolute error or anything else. This is about the decision tree. Any doubts you can ask. Hello, am I audible?
Yes,
Yes,
sir,
sir.
you are audible. You are
Sir,
audible.
audible, sir, audible.
Yes, yes. You can ask any doubts now on this. Okay. Now we'll see the first. We'll see the random forest. Then we'll before taking a break, or we'll take a break now.
Sir, break will be from 3 to 3:15, sir.
3 to 3:15. So
3:15.
15 more minutes are there.
Yes.
Yeah.
Hello.
Yes. Hello.
Sir, I have a doubt. In the first day, decision tree can be used as a regression model and classification.
Yes.
It is not used in clustering. Why can't we use in clustering, sir? In clustering also we can divide into two groups or something like that.
No. Clustering. It is unsupervised learning. There is no target variable for clustering. Understood? For supervised learning, are you getting my point?
Yes, sir.
Clustering is different, classification and regression is different. Understood? Uh, First of all, machine learning, supervised and unsupervised learning. Supervised learning means when we have a target variable, then we can apply supervised learning. Target variable means, for example, this is Apple. So Apple is an object. Name is there. Apple name is there. APPLE, Apple name is that is a target variable label. Then we can apply supervised learning. Understood? This is an orange. Name is there, label is there. So that is a supervised learning. So clustering is here, grouping of similar data items. Similar data items we are grouping here. Okay. There is no particular target variable. In clustering, grouping of similar data items, there is no proper target variable. Let me give one example. For example, you have 1,000 fruits. You don't know their names. You have 1,000 fruits. There are different fruits are there mixed over. 1,000 fruits are there. You don't know their names. Means I'm saying that there is no label. There is no label. So just you have fruits. So I'm asking you to just group them based on your choice. I'm asking you to group the fruits into the basket. Okay, group them, that fruits, into a basket. So what you will do, how you are going to do, give for example, for person 1, he is going to check the color. He is going to check the color, and red color in one basket, red color fruits are in one basket, all green color are in one basket, all white color in one basket, all blue color in one basket. So he extracted the features, or extracted the feature is color. Based on the color, he grouped them. The person 1, person 2 divided them based on a taste or based on a weight. Less than 1 kg, one basket. 1 to 2 kg, one basket. 2 to 3 kgs, one basket. Here, approach is correct. What they did, it is correct, but will get different output. What they did, person 1 divided the fruits based on a color. Person 2 divided the fruits based on a weight. Different features they extracted, so different outputs they got. Here, approach is correct. What they did, approach is correct, but they got different outputs. This is called clustering. Based on the features, you will get the clustering, because there is no supervision. There is no supervision. Whatever the features you select, the output you will get. Understood? In supervised learning, same 1,000 fruits are there. 1,000 fruits are there, but each fruit has a sticker on it. A sticker on it, like APPLE, apple. On apple fruits, a sticker as apple, banana, watermelon. Like that, a sticker is there. Now, I'm asking person 1 to separate them. What he's going to do? How it is going to do? Just read the sticker, read the label, and separate it. Supervision. Second person also, I'm asking, go with the sticker. Based on a sticker, separate it. So in these cases, when there is a supervised labeled data, the output is same will get. That is a supervised learning. So division is not same in these cases. In the first case, clustering, uh, there is no supervised data, but for the uh, second case, there is a sticker on it, then it is a supervised learning. So this decision tree can do based on the target variable, based on the label. So which feature is most relevant to the target variable, that feature we are selecting as a root node. Understood?
Yes, sir.
Yes, yes. Still any doubts? So I'm going with next random forest. Just 10 minutes are there. Just I will give you the introduction about the random forest. Before going to start the random forest, give me the introduction. This is not a primary model. Like what? This random forest is a not a primary model. Not a primary model. But when we are taking C programming language, integer is a primary data type. Character is a primary data type. Float is a primary data type. But when you want to handle more data, When you want to handle more data, like uh, 10 elements with the same name, so we are going to arrange one array. We are going to select one array or one character, sorry, string or structure. These are derived data types. From primary data types, we derived the data type. That is, they are derived data types like arrays, strings, structures also. They are basically derived from the primary data types. So here, random forest is also random forest is also not a direct machine learning model. It is a derived one. Derived one means we are going to mix two or more primary machine learning models to get this random forest model, like that. Two regression models or one regression, sorry, linear regression model, three logistic regression models, or two decision trees, four decision trees combining together to we can form a random forest. Okay, these models are called ensemble models. Ensemble learning, this approach is called ensemble ensemble learning. Means as of now we have the models like machine learning. It is divided into supervised learning, unsupervised learning. Supervised learning again, regression, classification, unsupervised learning, clustering. Regression purely it is linear regression. Clustering, logistic regression. Next, decision tree. Both we can do regression and classification. Support vector machine. Both we can do regression and classification. Next, k nearest neighbors. Both we can do regression and classification. These are the basic machine learning models. Here clustering means k means clustering or db scan clustering or hierarchical clustering, many things. These are the primary models, machine learning models. But here, by combining one more than two, by combining more than two models, we can do ensemble learning. We can create ensemble learning models. In that, one of the ensemble learning model is random forest. So random forest is a supervised learning model, can do both regression and classification, but it is ensemble learning. Ensemble learning means combining two or more machine learning models to create one big model, one big stronger model. You know, one heavy person is there, a big person, big person. These are our machine learning models. There is a war between these two. There is a war. Here is a big person. But one simple machine learning model can't defeat this person. So what we are doing, we are adding the strength, adding these two, if not adding these two also, to defeat this big person, to handle this big data. Whenever a simple machine learning model is not able to handle, not able to handle means either it is getting overfitted or it is getting underfitted, it is not able to handle, then we are going to combine two or more machine learning models. The process of combining two or more machine learning models to create one big model is called ensemble learning. Is called ensemble learning. Here, small model means when we have a small data set, they are good enough. When we have a small data set means with respect to that small data set means according to the model, that is a enough data set. But when there is a huge data, they are unable to handle, they are getting overfitted or underfitted, then in that situation we are going to mix the models. We are going to combine the models to create one big model to handle the data set, to provide a best fit model. So this approach, this combining is called ensemble learning approach. And one of the ensemble learning model is random forest. One of the model is random forest. This is how many ways we can combine. Okay, we can how many ways we can combine them, how we can provide the results. Based on that, we have 4 variations. That 4 variations we'll see now. So when we are getting overfitted, either it is getting same decision tree only. Here the tree is getting underfitted, means accuracy will not be satisfied. Will not be satisfied. Uh, how many number of times you tried? Said I will try 10 iterations or 100 epochs, 200 epochs. I will try for all the epochs. The average accuracy is this much only. Then we can completely decide this model is unable to fit. This model is unable to fit. So we need to improve the performance. Improve the performance. If it is 1 iteration, go for the 2nd iteration, 3rd iteration. But all the iterations you got this, that is called bias. That is called bias. Means for example, we trained a model for 10 iterations. Average of 10 iterations, the accuracy is this much only. Then we can say the model is getting biased. Not enough. We need more strength. That is underfit model. Here also overfitting by harding, very big tree. By harding, uh, training accuracy is good, 100%, 90%. Testing accuracy is very less. Then it is getting overfitted, and here it is getting underfitted. So in these situations, either when a model is underfit or when a model is overfit, not able to provide a best fit model, then we are going to combine 2 or more models. Then we are going to combine 2 or more models to provide a strong, robust, best fit model. That is called ensemble approach. Ensemble approach. So multiple models we are learning, combining. What multiple models? What basic models only, like linear regression, 2 linear regressions, or 3 linear regressions, like 3 logistic regression or 1 logistic regression plus 1 decision tree. We may combine anything. Okay, we can decide the role of each and every model also. That's what are called weak learners, combining together to train on the given data set to provide the best fit models. That is called a ensemble learning. Ensemble learning means combining 2 or more models to provide a strong model. That is called ensemble method or ensemble learning. In this, random forest is the one of the ensemble approach. One of the ensemble approach. So how we can combine, how they are going to train, how we can combine, we'll see in after the break then. Sir, now okay?